So 7-4 is your homework. We might get through 7-5 also. I don't know. But so we have this clown car, and the clowns have, because you know their foot power, they're kind of going Flintstones here.
Where's his legs?
Don't worry about it. He's a clown. Because they're foot powered, they've only been traveling for a half hour. Now, because they've been traveling for a half hour, they've traveled 10 miles. So we could set this up that they've gone distance, they're 10 miles, in their time, 1/2 of an hour. But that doesn't really make sense. We don't talk about speed in rates of half hours.
Why do you have so many gnats in your house?
So, how could we figure out what their speed actually is, how we normally talk about speed? Sheed?
20 miles per hour.
Now, how'd you do that?
So it's like, so there's like 1/2 an hour, so you usually do miles per hour, so you have to make it into 1 whole hour.
We normally do miles per hour, which means 1 hour, because, hello, if we're dealing with unit rates today, unit rates are always per one of something. There's always a 1 in the denominator. So Shahid says, well, to do that, we just multiply by 2, so that means we're traveling 20 miles per hour. And that's all we have to do to solve unit rates that involve fractions. Now here's the problem. What if it's a fraction that isn't 1/2? What if it isn't as nice to you? Oh? Yeah.
How would you stop that car?
How would you what?
Stop that car.
Stop walking.
But what about the momentum from the wheels?
Have you guys ever seen the Flintstones?
Yeah, but like.
Okay, that's what they're trying to like
Oh, so
smooth
it's like a
things.
paper car. It's not really a car. They're just like holding it up.
Sure, we'll go with that.
Suppose you
Alright, so check out this problem. I know it's solved out on your notes, but check out this problem.
Yeah.
Per is always representing a division. So if we want the miles per hour, well, now we have 2 fractions here. So we're going to set up 3/2 of a mile divided by 3/4 of an hour. If my smartboard would let me grab. So when we set that up, then like we talked about yesterday, we have a few different methods that we can solve this through. If I take 3/4 and divide it by 3/4, any number divided by itself is just 1. But really, division of a fraction, what do we actually do when we have a fraction divided by a fraction? What's that 3-word process that we always want to remember? Nate? Keep, change, flip. So really, my numerator here, and what you want to write on your paper, what's actually happening is 3/2 times 4/3. These 3's can cross cancel out. My 4 and my 2 can cross reduce to 2 and 1, and I just get 2/1, or 2 miles per hour. The other way you could have done is start this by just saying 3/2 divided by 3/4. Your miles divided by your hours, and then just keep change flip from there. You don't even have to set it up vertically to begin with. You could just set it up with the horizontal division. So, let's try your first problem. And I think you guys are pretty sharp, so go ahead and try that on your own. We have a recipe that calls for 3/4 cup of dry milk to make 6 dog biscuits. Now, if you still are trying to figure out a Phoenix Fair idea, we've had people make dog treats, and it turned out like really well. They sold really well. They were just like peanut butter dog treats, and there's recipes all over the internet. How many cups of milk powder do you need per dog biscuit? What do we know based off the statement of it saying how much milk do you need per dog biscuit? Right? It's going to be 4 each, but what's that tell me about the math I need to set up? Lily? We're going to divide, yeah, but what divided by what? What's the order of this division going to be? It's that.
The milk divided by the dog.
since it says per dog biscuit, that's telling me divided by dog biscuits. So that means that my milk value has to be first. So I take my 3/4 cups of dry milk divided by my number of biscuits, but that's 3/4 divided by 6.
I know.
Now hold on, I'll come back to you. If I set this up the digits way, the way that we see it if we like ask for help.
No.
One, chill. Do you know what method I'm going to take here?
Yeah. No.
Not the keep, change, flip method?
No, I'm not doing keep change.
multiply this.
I would, yeah.
Multiply what, Rye?
Don't you multiply
I want
6?
So, here's what, we're going to look at a couple different ways to solve this. Do you know what I'm going to multiply by?
The numerator's denominator.
The numerator's denominator. Because I want to get rid of this fraction in the numerator. So if I multiply by the denominator, those wipe each other out, but I have to do it on top and bottom. Then I would get 3, because the 4 actually doesn't do anything except wipe out the other 4, over 24, which ends up as 1/8, which would be my answer.
Can you get it a different way?
Yes. So hold up. Back to Zach, because it was Zach's problem. Zach, if I set this up as my 3/4 divided by 6, what do I really need to do with that? Zach, you still with me? What do I need to do with that before I can apply my nice, easy keep, change, flip property?
Oh, okay. I have it.
So make the 6 over 1, and then
Make it a fraction.
so that's the keep making, and then the change is make the division. No,
Remember, it happens in order.
yeah. Then well, so do the 3/4, and then put the dot for multiply, and then flip the 6 and the 1 to be 1/6.
Yep.
And then multiply.
So then that gives me 3 over 24, just what I had before, and it reduces to 1/8.
You can cross cancel.
But we could cross reduce, not cross cancel. But when I write this answer, I need a label. Some of you are getting really lazy, and I'm gonna start marking those answers as half credit. And you'll come up and be like, why did I miss half on this? Because if you don't put a label, it makes me think dogs, cats, pizzas, what are you talking about? So Karen, what would be my label here? Yeah, cups. I'll abbreviate cups as C. Cups of milk powder. Cups of milk powder, what? Per biscuit. And I don't need to say 1, because if I only say per biscuit, then I know I'm talking about 1 biscuit. So that's 1/8 cup of milk powder per biscuit. So if I have 1 cup, like that's all I have left, how many biscuits can I make? Olivia? If I use 1/8 of a cup per biscuit. 8. Because each biscuit uses 1/8. If I have a full cup, that'll make me 8 biscuits. Question?
Okay, so the digits way
Yeah,
is like
gone now.
on now, but is it the same thing that I was talking about yesterday with multiplying the numerator's denominator by the denominator?
Yeah, but you do it in both places. That's the thing that you're like, I think you didn't say that, and that's what confused me. It's kind of like an equation. When we're working with a fraction and we multiply the denominator, we have to multiply the numerator also to keep the fraction like the same. Try this on your own. Pay attention to the order of the phrasing. Your dog eats 7/8 pounds of food in 4 meals. How much food does your dog eat per meal? So really you're talking about food per meal. Don't feel bad about the dog. This isn't weight. Dog food does not weigh that. Right now I have 3 huskies at my house making my life crazy.
3 dogs?
I have 2, but we're dog sitting my mother-in-law's dog, Nika.
love this.
I know, but you just did the last one. So I'm gonna choose somebody else. Well, it does mean that I need to choose somebody else to make sure that everyone knows what they're doing. Yes, that's why I was walking over here. Thank you for the suggestion. If you'd like to operate as though that you made me do this, then okay, sure.
I could also draw the cards.
Kids normally don't trust it when other kids draw.
Draw the
You
cards.
draw mine on your thing.
Huh?
After you rig it
It's gonna be
all
Olivia.
I mean, I can't. That's not the question that you want to
Olivia
ask.
always gets picked.
All right,
Oh my goodness.
Ella
Whoa. Your
on
name is
top.
on the top and then
All right, a hush fell upon the audience, and Ella is going to talk us through how to do this. What order does my division have to be set up in?
It would be what the 8. Okay, so 7/8 divided by 4.
Yeah, because of the phrasing, it's really food per meal. So it's really the 7/8 divided by the 4 because it's food divided by how many meals. Now what do I do, Ella?
Okay, so you can choose that. So
How can I flip something that's not a fraction?
it's 4/1.
I have to make this a fraction first by putting it over 1. Then we apply KCF. So then this becomes
7/8
7/8 times 1/4. That then becomes
7/13.
7/30. And can that reduce?
I don't think
Really?
into a complex fraction.
no.
7's prime. So unless 32 is divisible by 7, we're stuck.
It could be a decimal.
And 32 is not divisible by 7. So that's going to be 7/30. Hey, chill. You could change it to a decimal. That wouldn't be reducing. That'd just be converting to a decimal.
I mean, no, he said he was gonna put like decimals
chill.
in a fraction.
Chill. It's okay. 7/32 pounds.
It's hard to chill.
Yeah, pounds per meal.
It is pretty hot.
The word meal sounds weird.
Whoa. What's the unit?
What? That is, so that's the pounds he eats every meal.
Oh, okay.
Now think about this. Hey guys, can we stop with the side chatter? Like it's really, I don't know what's going on today. Full moon's over, Halloween's over, get over it. So, approximately, let's say we wanted to go to decimals. What fraction that's close to this would be a lot easier to work with? Zach?
45. Like 7.
Okay, 7/35, that would be easier. So one potential approximation we could do is 7/35, which reduces down to
1/7.
1/5 actually, which is 0.2. So about 1/5 of a pound or 2/10 of a pound. Or another fraction we could work with, Pranav.
Could we do 4 over 32?
Ah, that's too far away. But if we did 8 over 32, that's about 1/4, which is 0.25. So it's between these two values, approximately 0.22, 0.23, somewhere right around there. If you didn't want to use a calculator to convert this. I'm hot. You know, if you're hot, take off anything on your wrists, expose your ankles.
Or a winter.
That's where that's where heat escapes from, is your ankles and your wrists. Yeah. No, trust me, it's hot in here, I know. Now, be careful. These are the same exact values, but it's not the same exact problem.
Oh, snap.
Solve it on your own. Solve it on your own. You're lucky you didn't apply food tax. Said you're lucky you don't apply food tax. You have to be tax
I do.
Hey guys, if your work isn't done, you shouldn't be talking. Look at what it's asking. How many meals will it take to eat 1 pound of dog food? So now the 1 is the pounds. So that tells you that the pounds are going to be on bottom,
I know what I'm doing now.
Now we do.
and meals is going to be on top. That's what we're looking for.
It's the same thing.
No, it's not. The last one was pound per meal. This is meals per pound.
So you have to find
It's
the unit
quite
rate.
easy.
Wait, so approximate.
We already have everything done. It's so easy. I mean, I use my calculator, but you literally do one equation.
That's
you
why
use
So wait. We don't even actually have to do anything. Do you know what the easy way to find this answer is, Jackson? Or, yeah. For a second I thought I called you. I know. For a second I thought I called you Grayson.
So I use the calculator because it goes quite far. So if we already know that from our last problem that 72 7 over 32 pounds per meal, then all we
Be
have
careful because that looks like that's equal right now.
oh
So for a second, let's just do that.
okay yeah. So if 7 over 32 is equivalent to what we eat, dogs eat, per meal, then all we have to do is divide, wait, yeah, 7 by,
Takes practice. And you don't have to put pen on it, just to push the whole eraser onto it. It's got to have multi-touch. Yeah. It's got to sense multiple points.
So if, yeah, so, wait. So, what I did was, since we have 32 total as a pound, all we have to do is divide that by 7, and which it may like it doesn't look quite right over here, but if 32 is how much we're eating, and that's equivalent to 1 pound, how many times would we have to multiply 7 to get 32? And that would be wait, 4, and it goes on for a while. And so that's how many meals we would have to eat.
So I think that's one of those situations where it makes sense in your head, and it's right, but it's kind of like difficult to see. And I'm going to tell you a process that's way simpler and might make you face palm. Your answer's not wrong, but there's an easier way.
Would you just divide 4 divided by 1?
Wait, no. I have a question.
I'll question.
I have a question. What would that be equivalent to?
Fraction form? Right, that is the good question. What's that equivalent to?
I did it in fraction form, so now I'm not sure if I'm right. It's like,
I'm going to let us get to the face palm moment.
wait.
James, you haven't really said anything today.
Alright, so you just flip the old answer upside down.
Wait. Listen to James.
You just flip the old answer upside down.
This problem is the reciprocal of the previous problem. So your answer is the reciprocal of the previous problem. It's just 32 sevenths, which is what Jackson did, but he just made it a little bit more complicated. Because we could have gotten there if we had to work through the process to get there. You take your 4 meals divided by your 7/8, you keep change flip, and that's how you get 32 over 7.
which is then in a mixed fraction, it's 4
Which is 4 and 4 sevenths, which is why Jackson had like 4.4 whatever. Like that's what this is as a decimal. No?
So basically, since we're having the order change from last time, because before we had 1 over 4, or reciprocal, now we have 4 over 1. So, it changed. So,
But that's not the reciprocal. This is my beginning value. What we take the reciprocal of now is the 7/8, which becomes 8/7.
So that's why basically, that's why, like, say if 4/1 is supposed to be the reciprocal, it's
You're getting confused. The easy way that this is because we start with meals divided by pounds. That is the reciprocal. The problem's gone now. But that's the reciprocal of the previous problem, because the previous problem was pounds per meal. Now we flipped that upside down and said meals per pound. So all I have to do is flip my answer. Olivia?
Okay. Okay. So in that problem, don't take it away yet.
It's up there.
No, not that one. I meant. Okay, fine. You can take it away.
Okay.
So in the problem, it says 7/8 of a pound is in 4 meals. So you can kind of infer what it's going to be around from the problem because 7/8 of a
Yeah,
pound.
it's almost a pound, right?
Yeah.
Like it's almost there. Yeah, so we know it's going to be just over 4. Yeah, it's like just 1/8 of a pound away. Karen? We wouldn't really need to. I mean, we could. Write these as unit rates. I'm going to give you 60 seconds. Go. I'm going to give you 60 seconds. Now that's 56 seconds.
Well, hold up. So what were you gonna tell me to talk?
You don't have to reduce.
I mean, you have to simplify into a unit rate.
Yeah, I'm still gonna reduce.
Why is it working?
Because I have it frozen. This is probably going to look bad, I warn you.
Got it.
Ah,
Yeah, you're right. Whoa, got it.
it looks a little messy.
I did it. I just
So the last one here is my smart board's getting goofed up. So when the denominator is an easy fraction, just think, what do I do to that fraction to turn it into 1? Well, to turn 1/4 into 1, you just multiply by 4. So you do it on top and bottom. 4 times a half is 2. My label would be miles per hour. 1/5, to turn it into 1, you just multiply by 5. So I multiply by 5 on top. I get 35/10, which is really just 3.5. My label there would be feet per second, often abbreviated FPS. We can always multiply by something's reciprocal to turn it into 1. So here in C, I multiply by 3/2 on top and bottom. The bottom, or the denominator just gets destroyed, and I'll get 12/10, which is about 1.2 kilometers per minute. Sorry, that's an equals. And this got really messy because of the smartboard. We multiply it by 6/5. Denominator disappears. We get 90/20. Olivia reduces to? Yep. Yeah, 9/2, which then reduces to 4.5. That'd be meters per minute. Yeah.
So couldn't B also be reduced?
Yeah, which is still 3.5. No,
No, that's
6 halves. 7 halves, not 7/5, 7 halves.
7
Yeah. This could be 7 halves if you reduce by 5. Divide by 5 on top and bottom. But 7 halves is 3.5. Questions on any of these? Cool. Try the got it on your own. When I'm not at practice.
It's only cool when it runs.
It's
No,
only
wait,
cool.
wait,
All right.
wait.
The biggest and probably the only mistake I saw as we walked around is setting up in the wrong order. Per is the indicator of your order. I sometimes even start by writing out pounds per square feet just so I don't get the order wrong. Now, Noah, you said something very profound as I walked around here. What'd you ask me?
So I just noticed that it's 1/3, and you just multiply the 1/5 by 3.
We have a third of a square foot. How many thirds does it take to make a whole square foot? 3. So Noah said, can't I just multiply my pounds by 3? Yes, you can. Because if you think about setting it up as 1/5 pounds per square feet,
You have to multiply that by 12 though, because it's... Oh, never mind.
all we have to do to get 1 square foot is multiply by 3. We do that on top and bottom, and we get 3/5 pounds per square foot.
I got it wrong.
Yeah, you got it right.
I got it right.
Check your order. If you got it wrong, you probably did it in the wrong order. Ella?
Yeah. So I didn't really do it, but couldn't you just like change that?
Mm-hmm. Here, I could have also pounds per square foot. I could have said 1/5 divided by 1/3. I keep change flip. I'd get 1/5 times
That's what I did.
3/1, which gives me 3/5. Either way, same answer. Other questions? Cool. We have a fuel economy study. Every new car that comes out pretty much has a fuel economy study attached to it. So we've got 2 different cars. So, 2 different cars. I can get this out. So figure out which car can travel further on 1 gallon of gas. So will your gallon be on bottom in the denominator or in the numerator? If we're looking for a unit rate and it's giving me 1 gallon, since my 1 refers to the gallon, I'm assuming that my miles will not also be 1, because that would be a terrible fuel economy. So you're going to do miles per gallon, so you can get 1 gallon. The unit rate, the 1 has to be in the denominator. Question?
Yes.
Okay.
I don't know if this would work, but could you make RB convert the 1 to be 5/4 and then
Mhm.
just make it somehow?
Mm-hmm.
Is that possible?
Mm-hmm. So what Zach just said is, can't I just make that 5/4? The 1 and 1/4? Yeah, you can. I'm actually going to hop over to the notes page so I have some blank paper to do this on.
Oh,
Yeah.
How do you figure out how to set it up?
So, since it gives me the distance traveled on 1 gallon, that tells me I want the miles we can go per 1 gallon. And unit rate always has the 1 last, or the 1 in the denominator. So for car A, and I'm just going to make them all improper values. Car A, 18 2/5. 92 fifths. Divided by my gallons, which is 4/5. I keep, change, flip it. I'm not going to change colors, so I'll use a different color for car B. Hey guys, look at how easy some of these things get without using a calculator. We can cross cancel the 5s. Now the question is, can we cross reduce the 92 and the 4? 92 is actually is a factor, or is a multiple of 4. 4 is a factor.
93, right?
Because 80, we know is a multiple of 4. Put 12 more on it. Well, 12 is a factor of 4. So that'd give me 23, actually. So that becomes 23, and this becomes 1. So I get just 23 miles per gallon.
Yeah, but it's
The 5's canceled. So the 5 here becomes a 1. The 5 there becomes a 1.
But
Yeah.
that doesn't, the 4.
92 was a multiple of 4, so we cross-reduced the 92 and the 4.
That doesn't answer the question.
Not yet.
That's
We're there.
car A can go 23 miles on 1 gallon. So actually, if you watch Mythbusters, they did a survey thing one time where they wanted to figure out the exact distance you could travel. So they drove the car till it was empty, like rolled to a stop. It couldn't go anywhere. Then they put in exactly 1 gallon of gas. Their myth that they were testing was windows up versus windows down. Like windows up, air conditioner blazing, like as cold as you can get it. Windows all the way down because you have more wind resistance. But your air conditioner, the power it uses is generated by your engine, which has to burn gas to make energy.
Can we watch that?
I'm not going to tell you.
I'm watching it.
So then car B, I do the same thing, 28.5 miles turns into an improper of 57 over 2 divided by my gallons, which was 5/4. I then keep, change, flip. That's going to become 57 over 2 times 4 over 5. There's only one cross reduction that's able to happen, 2 and 4. Becomes a 1 and a 2. 57 times 2, that now becomes 114 divided by 5. 114 divided by 5 is going to be very, very, very close to 115 divided by 5. But it's not quite there. 22.8. I just wanted to verify.
Oh, that worked.
So although they're very close, which car can go farther? Car A, it has more miles it can travel on 1 gallon. That's probably why it gets less miles per gallon.
It has a
Maybe it's got like a 10-cylinder or 12-cylinder engine as opposed to.
yeah, it'll probably win the race though.
Yeah, it might be going faster though. Yeah.
So say if you had a van or something bigger, with a
It depends on how everything is tuned. There's a lot that goes into what makes your miles per gallon. And actually, most cars are tuned that their optimal miles per gallon will be at about 55. So when you're driving 70 on the highway, you're getting less miles per gallon than you could if you only drove 55. Because that's how the car is set up. Figure out who ran faster, you or your friend. I'm going to give you 90 seconds to do this.
Oh, right.
Hey guys, we don't need the sound effects. Thank you though.
Sorry, we're very passionate about our band sometimes.
You want to teach it? You want to write your stuff out right now?
Hey, can you check it for a sec?
Is that 7 over 2 and then you cross canceled it?
Yeah.
Okay. So for a second it looked like a 12. Yes, but write out the division and then show the KCF. Yeah, should be good. If you need help, please raise a hand. All you guys are skipping steps, which is okay.
It's really at
friend ran 7/5, not 7/2. Careful.
Okay.
So we take your miles, your 7 hours, divide by your hours, equals, but then we take a fraction of that fraction. That will keep us change multiplications for lift and second fraction. I can cross reduce, and 4 and my 2 both share a factor of 2. So I divide them both by 2. The 7 and my 2 can't be cross reduced. So it's 14 over 3. You with me through these steps? That makes sense? So then that's very cool. So it's going to be 4 and 2 thirds. And then the other one is miles per hour since I did it. So go ahead and solve for your friend and the miles per hour. Be careful. I will draw a line there to show that there's like 2 different lines. Okay, then right. So you're gonna hide it. You did hours per mile. Miles per hour. Your division's in the wrong order. How we doing?
Here's all the math.
For this one?
I
So
did
make sure you do this one.
Okay.
Alright, Peyton, explain it real fast for us.
Okay. So,
Everybody needs to be quiet so we can get through with this and get out of here.
so 3 1/2 is equal to 7 over 2 divided by 3/4, which then goes into KCF, and you have 7 over 2 times 4 over 3, which is 14 over 3, which in mixed fraction is 4 and 2 thirds. And then for your friend, 1 2/5 then makes 7/5 divided by 1/3, which equals 7/5 times 3 over 1, which is then 21 over 5, which in a mixed fraction is 4 and 1/5, and that means you ran faster because 4 and 2/3 is.
Yeah, slightly faster, but you ran faster, and that's what matters, that you're better.
Yeah, I know right
All right, thank you guys. Please prepare for your mastery chapter 6. Mastery tomorrow.